Hello all, welcome to Public Cloud Design Tips and Tricks again. Today we'll be discussing a very interesting topic. It's Microsoft Fabric, and in this session we are going to discuss about the fundamentals of Microsoft Fabric. Now, a little bit on what is Microsoft Fabric in short. In short, Microsoft Fabric is a unified analytics solution for organizations which covers data movement to different data engineering and data science environments, real-time analytics, and business intelligence in a single window offering. Now, Data Fabric or Microsoft Fabric, it offers a comprehensive suite of services such as data lake, data engineering, and data integrations all in a single window. Okay, so that is a very high level definition of Microsoft Fabric. Now, let's start with a very common example. Okay, the business problem here is you have to you have to have a business analytics engine or business analytics platform that will help you to do a business decision for a product performance strategy. Okay, say for example it is required for a retail industry. Okay, so that's the problem statement. So if you just if you just sit and think about it, how it works is, you have to develop an analytical system where you have to pull out data from different sources. For example, sentiments of the customer, trends, the current trends, the performance of an existing product, and different feedback mechanism. Okay, so these are different data sources where you have to collect different data informations. Okay, and now you have to build an analytical capability on top of that that will provide you a strategy for your product performance or how your product is doing in different store. Okay, and based on that, the uh, the person of the organizations or the decision maker of the organization, they can take a business decision. Okay, so this is not a very simple example. Now, if you try to translate that particular business problem into a simple data journey or the developer journey, then how it looks like. Okay, so in a traditional data flow scenario, let's go step by step. A traditional data flow scenario, there there should be a platform or there should be a software that will do lot of stuff. For example, at the first step, it is data ingestion. So what is data ingestion? So there will be a application or there will be a process that will pull out all the information from data information from different data sources, S1, S2, S3, and S4. These are the data sources. Okay, here. And now when you have all the data aggregated to a platform, then you have to engineer the data. What it means is you have to collect all the necessary data and transform into your required format. So that is about engineering the data. Okay, and once you engineer the data, then you have to store that data for further analysis or for the reporting purpose. Okay, after storing the data with your necessary requirement, you can also create different models using machine learning kind of a methods. Okay, so you can create different model to do different or uh, to take different business decisions. Okay, so that is all about modeling the data. Now once you have the data stored in a storage, then you can also create a reporting. Okay, you can create a reporting dashboard to provide all the necessary information to the decision maker. So that is how it works in a user journey basically. Now if you try to transform into this into the user journey into the services or technology that you can use within Microsoft Azure, is first when you are actually trying to move the data from the source to your engineering environment, you can use Azure Data Factory. Okay, now once you have the data, in the storage. Let's say you can bring all those data or pull all those data into a storage that can be Azure storage, and from that Azure storage you can start engineering the data. Okay, so to engineer the data, you can go for Azure Synapse Pack or you can use Azure Databricks. Okay, so these are the services where you can engineer the data. Now once you have already engineered the data using these services, you you will store the necessary data or the transform data, or the required data, you can say. So for that you can use Azure Synapse or Azure SQL. Okay, so once you have the required data in Azure Synapse or Azure SQL, then you can create a reporting tool using Azure Power BI. Okay, so these are the number of technology you can use within Azure, within Microsoft Azure. Now in course of journey, let's say if you have to do some real-time analytics, then you can use Custo database, and you can write Custo's query to create your own event alert mechanism. Okay, so that is where you can use Custo database. And if you want to store that data and to create some custom uh, custom query or something, you can also use Azure Data Explorer. So this is how different services within Azure boundary you can use to develop a decision engine. Okay, within the data landscape. Now, from a developer perspective, or from a service user perspective, who are the actor for this particular user journey are the data engineers. Okay, the first is the data engineer. What normally a data engineer does, they are responsible for engineer the data using Synapse or Database, all those things. Okay, now a data analyst can visualize the information using a reporting dashboard. So those are the people who actually develop that Power BI capability for to report the information. Okay, so and within the machine learning space, Azure machine learning to model the data, data scientists can work to develop different data models. Okay, or ML models, machine learning models. So these are the actors basically. They work on this kind of an integrated platform. Okay, so we have discussed various services within Azure. We have discussed who are the consumer of those services, and we discuss what are the services that can play different role in different perspective. Okay, so that is how the data journey works. Now, what is Microsoft Fabric? Okay, so all the things that we discussed in our previous slides, Microsoft combines all those capabilities into a single offering, and that is your Microsoft Fabric. Okay, so now if you see the left hand side, then you have different Fabric items or Fabric services like Data Factory, Synapse Data Engineering, Synapse Data Warehousing, Synapse Data Science, Synapse Real Time Analytics, and Power BI. So Data Factory is responsible for data movement. Data engineering is responsible to engineer the data using Spark capability. Data warehousing is more for big data storage mechanism, warehouse mechanism. Data science platform is responsible to develop your machine learning models. Real time analytics will deal with your real time events capturing or real time analytics, and Power BI is for the reporting purpose. Okay, now the whole service items are on top of a unified storage, that is OneLake here. Okay, and the whole Microsoft Fabric is based on a software as a service foundation. So if you see here, it's a complete software. If you start using individually Data Factory the way it is happening now, it's more as a you know platform as a service. So Azure Databricks, Azure Data Factory, Azure Synapse Analytics, those are platform as a service. But when you start bundling every services or every pass into a single unified window, then it comes as a software as a service to the end organization. Okay, so in the right side again, we I have explained data factory, data engineering, science, warehouse, real-time analytics, and Power BI. That all comes in a bundle within Microsoft Fabric. So it is a complete end-to-end software designed for organization to develop and maintain data engineering and data analytics initiatives. Now, again, to reiterate, the Microsoft Fabric components, Data Factory is used for data movement, and it comes with 200 native connectors to connect data sources on-premise or in cloud. Data engineering, already discussed, it offers a Spark platform engine, you know, uh, with great design experiences, enabling data engineers to perform large-scale data transformation and democratize data through Lakehouse. Okay, it uses notebooks, Spark internally. Data science, again, data science experience enables the consumer to seamlessly build, deploy, and operationalize machine learning models in your Fabric environment. So it is integrated with AML, Azure Machine Learning, to provide built-in experiment tracking and model registry. Data warehouse again provides large data management capability with scaling. Real-time analytics, we discussed events and observational data, which is an important space of in this bigger context, gets enabled with streams and database using various native capability like stream analytics and data explorer. Power BI is again meant for business intelligence reporting basically. Uh, so these are all the Microsoft Fabric components. Now the most fundamental thing here within Microsoft Fabric is OneLake. Okay, so the data lake is the foundation of all Fabric services. Microsoft Fabric Lake is termed as OneLake here. Okay, so that provides a unified location for storing all organizational data where the software experiences work. Okay, so for every Fabric item we have seen, the Synapse engineering, then Synapse analytics, Synapse warehouse, all those items are working on top of a unified storage, and that is OneLake. So OneLake is built on Gen 2 Azure Storage Gen 2 technology. It provides a single experience for a single tenant basically. So within a single tenant, I will explain. It acts as a unified storage mechanism, and it simplifies the user developer experience by eliminating the need of using multiple subscription RGs RBAC. Okay, so you don't need to go for different subscriptions, resource groups, necessary RBAC setting. You don't need that, and if you are using a Microsoft Fabric, then it all gets unified into a single single umbrella. It solves the problem of massive data management in silos. Okay, so basically in the traditional way we are doing, there are different silos we maintain for the data storage, but if we start using Fabric, then it's actually remove the data silos for the massive scale. Okay, now it provides a unified storage across organization by eliminating data sharing and policy governance basically. So you don't need to worry about a lot about across the subscriptions, resource group and storage to handle your policy governance. So I have taken this image from Microsoft again. So this is how it looks like. So for a single organization, single tenant model, you can create multiple workspace for multiple purpose, or for multiple departments, or uh, multiple set of workloads, you can say. So here, if you see, there is a workspace, and you can create multiple workspace based on your requirement. And within that workspace, you can have storage for your Fabric items. For example, warehouse, lakehouse, Custo storage, data sets, all these things you can create. So that is how it looks like. So it always works on a per tenant basis. Yeah. So now, if you if you try to aggregate everything, again, this data I have taken from Microsoft is you have all the Fabric item on the top, and on below there is a unified storage which is 1 lakh, and this is being used by every Fabric items. For example, data warehousing, data engineering, factory, data science. those things. And in between that, actually, there are different methods where you can interact with the storage for engineering, analytics, reporting, all these things. So T-SQL, Spark, Kusto query, analysis services, those are different methods or techniques where you can do your data engineering works basically, and that needs a compute for the processing. So T-SQL, SQL processing, Spark processing, all these things, you need a compute mechanism, and within Fabric, there these computes are provisioned using serverless computing techniques basically. So this is all about how a Fabric looks like. So what we have discussed in this session is fundamental of what is a Microsoft Fabric, how it comes as a it comes as a software as a service. What are the different Fabric items that deals with the data movement, data engineering, data modeling, uh, analytics, real-time analytics, reporting, all these things we discussed. How what is OneLake basically? It's a unified storage mechanism, and how it works on a single tenant level that we have discussed. And maybe in the next section we can focus more on OneLake fundamentals. And yeah, that's it for this session. If you still want to know more about it, I have referred a Microsoft link, which is Fabric overview. So please go to the link and do your necessary homework to understand how Microsoft Fabric works and how the components looks like within a Microsoft Fabric. Yeah, that's it. Thank you and have a good day.